Okay, so we've been talking about these little things called ions, which are atoms that have either a positive or a negative charge on them. Naturally, atoms like to be neutral, so they don't have a positive or negative charge. They have a zero charge because their protons and electrons are naturally equal. But what we learned about ions is that when protons and electrons are equal, the atom's not always as stable as it could be, because when you have equal protons and electrons, that outer shell isn't always full. And atoms really want that outer shell to be full so they can be nice and stable. So what they do is they'll gain or lose electrons to fill that shell. Well, that helps them gain stability. But what they give up is that neutrality. So they no longer have a zero charge. They have a positive or negative charge, which it definitely is a trade-off. Atoms don't really like to have a positive or negative charge, but they're willing to do it so that they can become more stable. So what happens is they form these ions, right? So it's a more stable atom, but they have that charge. So they aren't really happy about that positive or negative charge. So they'll take it one step further and they'll try to bond with something to take care of that charge. So that way they can be stable and neutral. A stable and neutral substance is a really happy substance. So the way that they achieve that is through ionic bonding, which is what we're going to talk about in this video. So you have a couple of substances here, and we have sugar, ethanol, and vitamin C. C12, H22O11, C2H5OH, C6H8O6. A little bit different formulas, but what's something that all three of these have in common? Well, what they have in common is that their atoms are bonded together. You have in this case, these are molecules, and these molecules have these atoms that are bonded or stuck together to create a more complex substance. Okay? In order for those atoms to stick together, they have to be bonded. We call those bonds chemical bonds. All right? This is when atoms combine and they form new, and a really important piece here, more stable substances. Remember that atoms, they really are going for stable and neutral. That's the happiest state they could be in, is if they're both stable and neutral. So we look at this picture, and this is a very standard picture of water. So we have our oxygen atom here and our hydrogen atom here. How many bonds do you see in this picture? How many places do you see that two atoms are stuck together? Hopefully you said two. One, two. There they are. Two bonds in this molecule. Okay? And those bonds we've talked a little bit about when we talked about water as well. Okay? So ionic bonding is a very specific way that atoms are going to stick together. And not all atoms bond or stick together in this way. But if you have a metal and a non-metal, they're going to bond in this way. Okay? How ionic bonding works is that you're going to have a positive ion and a negative ion, and when you put them near each other, they're going to be attracted to each other, kind of like in polarity. So you have a positive ion, you have a negative ion, and when they get close to each other, that positive and negative are attracted to each other just like a magnet. Well, a magnetic bond, or magnets, when they stick together, that's a pretty strong hold they have. So this ionic bond is also pretty strong. Like I mentioned before, this is only going to happen if you have a metal and one non-metal, because metals are going to form positive or cations, and non-metals are going to form negative or anions. And the only way for this to work would be if you have one positive and one negative. Because if you have two positives, they're going to repel each other. They're not going to be attracted. If you have two negatives, they're going to repel. They're not going to be attracted. So you have to have one positive, one negative. In other words, one metal, one non-metal. Okay? So in your ion notes, we built sodium atom and we built a fluorine atom. We're going to do that again really quick. So if you look at the atomic number of sodium, it's 11, meaning we have 11 protons in the nucleus there. And naturally, like we said, atoms have equal numbers of protons and electrons. So sodium atom is going to have 11 electrons. That's what it looks like there, with one in the outer shell. Now let's build fluorine. Okay, fluorine has an atomic number of 9, so 9 protons. And it's also going to have 9 electrons. And there they all come. All right. All right, so are these atoms stable? Well, you ask yourself, do they have a full outer shell? Does sodium? Nope. Sodium has 1, and if this ring was full, it should have 8. Does fluorine have a full outer shell? Nope. So neither one is stable. And if you look at these, you can see that sodium wants to lose this little electron here. And fluorine has 7 electrons in its outer shell, so fluorine wants to gain an electron. So these two are looking at each other going, well, I want to lose one, and I want to gain one. Do you think maybe we could partner up on this and make both of us happy? And they say yes. So that's exactly what's going to happen is this sodium's like, all right, well, I want to lose it, and you want to gain it, so there you go. Now you can see that ring has nothing in it, so we can get rid of it. Sodium is stable, and fluorine is stable. However, both of these are ions now, right? Because this has 11 pluses and only 10 minuses. Sodium's going to have a +1 charge, okay? And we covered that in our ion. So if that charge piece is confusing, make sure you ask. Now, fluorine has 9 protons and 10 electrons. It has 1 extra electron, so it's going to have a -1 charge. Well, you can see here is your cation, and now here is your anion. Because this has a +1 charge and this has a -1 charge, now we got that magnetic attraction between them, and that's exactly what's going to happen. They're going to be attracted to each other, and that magnetic pull is going to make these two ions stick together. Okay? So once you have the two ions together, you have your +1 charge and your -1 charge. Those are going to neutralize, right? So now both of these atoms are stable, right? Because they have full outer shells. Plus, if they stick together, they're also neutral. And remember, as we said at the beginning, stable and neutral is the goal. So what's going to happen is these two will bond together, and we call that NAF. Okay, so a really good way for us to sort of model this is, I know it's kind of weird, but we're going to use squares instead of circles. Usually we draw atoms as circles, right? So sodium and fluorine, that's the example we just did. Okay, so I'm going to draw this box here, and you should too. This box represents 1 sodium ion, and sodium ions end up with a +1 charge, which we just walked through. So here's that 1 positive charge. Okay, fluorine atoms, okay, or ions, I'm sorry. Here's your fluorine ion. Fluorine ions end up with a -1 charge, so there's that 1 negative. Now, when you put these two ions next to each other, these two, the 1 plus and the 1 minus, when you pair them up, they're going to cancel out to be 0 charge, right? +1 and a -1 equals out to 0. So when you put these two ions next to each other, the overall charge of the whole thing is 0. Okay, so then we want to write the formula. So you ask yourself, how many Na ions do I have? Well, I have 1 box, so I have 1 Na ion. How many F ions do I have? Again, I have 1 box. So you have 1 Na and 1 F. You write that as NaF. Okay? Let's try another one. This time, we're going to bond. Oops, I'm skipping ahead of myself. When you write your formula, you always want to write the metal first, which is always your cation. Your cation's always written first. So you would not write this FNA. You have to write the positive one first, so Na and then F. Okay, and that's always true when you're doing ionic compounds. All right, so now we're going to bond magnesium and chlorine, okay? So you look at your periodic table, and you see that magnesium, when it forms an ion, has a +2 charge. So here's a box that represents 1 magnesium ion, okay? It has 2 pluses, 1, 2. We write the charges right in the middle. Okay, and chlorine, when you look in your periodic table, has a charge when it forms an ion of -1. So there's the 1 minus for your chlorine. So this box represents 1 magnesium ion. This box represents 1 chlorine ion. Now, when we put 1 and 1 together, is this neutral? Remember, they're bonding to become neutral. So we put this plus and this minus together, and that's going to neutralize. But then we have this leftover plus. So if we just have 1 of each, this is still going to end up with a positive charge because you have this positive charge hanging out all by itself. So what we need to do is we need to throw another chlorine ion in there. Now these will cancel out and these will cancel out. You have 2 pluses and 2 minuses, overall that equals a 0 charge, which is the whole goal of bonding. So then you ask yourself, okay, I got to write the formula for this. And you say, how many magnesium ions do I have? And you say, well, there's one box here. That's one magnesium ion. How many chlorine ions do I have? Well, I have 2 boxes of chlorine, so I have 2 chlorine ions. When you write that, that's a little cut off down here, but you have MgCl2 because you have one Mg right here and 2 Cl's, 1, 2 right there. Okay, so once you get it neutral, you just have to count how many boxes you have. All right, we're going to try a little bit harder one. This one is bonding aluminum and oxygen. Okay, look at your periodic table and determine what charge is aluminum going to have when it forms an ion. Aluminum has a +3 charge, so this box represents an aluminum ion, and it's going to have 3 positive charges. Okay, oxygen, when oxygen forms an ion, it has a -2 charge. So there's your 2 minuses. Okay, if you have one aluminum and one oxygen ion, is it neutral? Well, these are neutralized, these are neutralized, but this one is missing its buddy, right? So what do we need more of? More positives or more negatives? We need more negatives, right? So we're going to add another oxygen ion in there. Okay, you got to add the whole thing. So now you go, okay, we have one aluminum ion and 2 oxygen ions. Are we neutral? Well, now we have an extra negative charge in there. So we're still not neutral. These neutralized, these neutralized, these did, but this one is missing its buddy. So now you say, okay, do we need more positives or more negatives? Well, now we need more positives, right? So we better add another aluminum ion in there. And there it is. You have to add it. It comes with 3 positive charges. You have to add all 3. You go, okay, are we neutral? Well, no, we're not. You can see here that these 2 positives do not have a negative to neutralize them. So we need to now add more negatives. So we add another oxygen ion. All right. Now you look and you go, okay, does each positive have a negative to go with it? And it does. 6 pluses, 6 minuses, that's going to neutralize to 0. So now we're good. We know we can write our formula. So you say, how many aluminum ions do I have? How many oxygen ions do I have? And if you look here, we have 2 aluminum ions and we have 3 oxygen ions, right? So when you write it, it's Al2O3, just like that. You have 2 aluminum ions and 3 oxygen ions, 1, 2, 3. And this compound will be stable and neutral. So it's a very happy bunch of ions. Okay. At this point, if you have any questions, make sure you ask. Otherwise, you have some practice and a lab activity to complete.